Hello, hello. It's me again. It's Alex. Hi. Thanks so much for sticking here at Central Park Stage, and thank you so much for being with us today at MongoDB.local NYC 2024. Headsets on if you want to get your next session, the last session before the end of the day. Just a few items of housekeeping before we disperse and you end up with really fun beverages at the closing reception. Please fill out your feedback forms for all the sessions that you've attended today. It is extremely helpful for all of us to really learn from you and your experience and to really make the sessions even more helpful to you. Our presenters, they've spent a lot of time on it and we would love your feedback. So thank you so much again for your time, your attention, and your questions to come. So, without further ado, the last session of the day before our closing reception, and our closing reception will be here in this main area. So please mingle, enjoy, and hope you have a lovely rest of the day. So thanks very much. We have Julian Oppenheim and Gaurab. They are senior product managers here related to developer tools, and they are going to talk about how you can leverage the developer tools to make your lives easier related to all the things you've learned about today around data modeling, etc. So without further ado, Julia and Gaurab, please give a warm welcome.
Hi everyone, I'm Julia. I'm a senior product manager on the developer tools team here at MongoDB.
Hi everyone, I'm Gaurab. I'm also a senior product manager here at MongoDB, and I also work on developer tools.
And we're here to tell you how you can data model your way to success with the help of MongoDB's developer tools. To begin, I'd like to start with a story. My friend came to visit me from Albany a couple of months ago. It's a pretty standard trip, and she's done it before. It takes 3 hours by bus. I normally come to meet her, and then we go about our visit. This time, she texted me when she was 30 minutes away, and I went to meet her. The arrangement seemed perfect, but then things started to unravel. I waited for an hour and a half. She went to all 5 boroughs after entering Manhattan and didn't even end up at the destination she was supposed to, which was Port Authority. Basically, what should have been a very simple, direct path once she was in New Jersey ended up looking like this. She took a very roundabout route, could go into the details of the story later, but the point is that choices that the driver made throughout the journey led to a very negative experience for both her as the person on the bus and me as the person waiting for her. It was not what we expected, and it was all because of the path that she took. I know what you're thinking, what does this have to do with MongoDB? Well, data modeling is actually not that different from planning a route. Decisions that you make along the way can definitely impact your success and how good you feel about the journey. Could be a little daunting, but we're here to help, and we're going to talk about how developer tools can guide you along the best path. We're going to do this in the context of an app that Gaurab and I are building called Burrow Blazer. We felt inspired by my friend's story and also angry on her behalf, so we wanted to give people a tool to monitor rides and ensure that they go on the right route and that people are compensated if something goes wrong. That being said, the scope of New York State felt a little large for us, so we're going to focus specifically on New York City taxi rides. The app will look something like this. So it's a way to just get an overview of the rides that are going on and dig into situations where something went wrong. So over here, we have a trip overview. You can see the number of rides at a given time and different trends with regards to fare, et cetera. Trends are over here if you really want to see a chart, dig into an anomaly. And then lastly, we have fare disputes. So if something is wrong with the trip, the rider can open a dispute, and our support team, the end users of our app, will look into it. This is the use case that we're going to focus on for the rest of the talk. Despite having some great wireframes that our designer, Ben, put together for us, we actually are not very far with our app at all. We haven't done anything. We have an idea of our access patterns, but we haven't translated it into a MongoDB data model. What we're going to do next is take you through the development of that data model with the support of our different developer tools. First, I'll set up a local dev environment with the Atlas CLI, which is just our command line interface. Then Gaurab will talk more about our access patterns, think about how we should model the data, and use our VS Code extension to translate that into MongoDB. Lastly, I'll review our data model in MongoDB Compass, our official MongoDB GUI, and see if there are places for optimization. With that, I'll set up my environment with the Atlas CLI. Gaurab and I chose a local Atlas environment because it's really easy to get started and manage local instances with MongoDB through the CLI. I just typed a setup command, I use the default settings, and then I know I'm using the latest version of MongoDB, and can pretty immediately access my local environment. It will give me some connection options, which I'm not going to select right now because I'm going to pass it over to Gaurab, but if I did, it would just launch the tool of my choice already connected to my development environment.
Thank you, Julia, for setting that up for us. So next up, we're going to go through data modeling and how we can leverage the MongoDB for VS Code extension in our local development journey. First, before we jump into data modeling, I want to first look at our access patterns that our application is going to make. And these access patterns are derived from the top use cases that our support team has identified. So the first access pattern is about getting all disputes where the dispute type is fair. The second one is more about dispute investigation. So this means we want to compare rides. We want to compare prices for rides that originated from similar location and traveled similar distances. I want to compare it to the disputed ride. The next one is around analytics. So here we want our support team to be able to understand cost trends for rides that started given a time period. So before we jump into actually data modeling, first let's look at the two different data sets that we have at hand. The first one is trips data set, and the second one is trips dispute. Within trips data set, we have fields like trip ID, total fare, pickup location, drop-off location, and a special field called checkpoints, which is effectively an array where we're going to periodically send over the latest geolocation of the ride, so we just know where the last location of the ride actually is. And on the other side is trip disputes, where it's a very standard data set that we have, where we have the status of the dispute, we have the assignee, the dispute type, and the dispute reason. So something to note about our company policy is that we'll only allow one trip dispute to be open at a given time, and any subsequent disputes that the customers want to file will be processed in series. So due to that, here between trips and trip disputes, we have a one-to-one relationship. Knowing that we have a one-to-one relationship, we can jump into evaluating kind of two different options that we have to model the data that we have. So the first one being embedding, and the second one being referencing. With embedding, we have some pros, like you'll get a faster read performance, but also on the downside, you run the risk of having larger documents. And in MongoDB, something to keep in mind is you have a 16 meg of total document size limit, so we want to be careful about exceeding that. And on the referencing side, it becomes easier for us to model complex relational data, but it also comes off with its own trade-offs, such as transactions being more complicated and getting a comparatively slower read speed compared to embedding. And lastly, we also want to think about this common general guiding principle that we use for MongoDB, which is data that is accessed together should be stored together. So we ended up deciding that we want to embed the trip disputes data into the trips data, and there are three main reasons for doing that. Number one is we know that our support team is going to query for a list of disputes all the time, because this is actually in the homepage of the application. So we want to make sure that the read speed is as optimal as possible. The second one is looking at the trip disputes data. The thing that we can understand is it's a bounded data set, and we know that it's relatively small in size. So the risk of running into that 16 megs limit, just because we added this trip disputes data set, the risk is significantly lower. And the last one is related to what is listed at the top of the slide, which is because whenever our support team is trying to access disputes, they will always want to access the related trip data associated to the dispute. So we want to make sure that the data that is accessed together is stored together. So now that we've looked at the data model, we've created it, and something to note is in the background, we've created some sample data sets. What we want to do is see how we can use the MongoDB for VS Code extension, and more specifically, the playgrounds feature of the extension to populate the cluster that Julia had helped us deploy earlier. So here's something to note again is the playgrounds feature that comes with the VS Code extension is a full-fledged node environment. So I can do things like import my node modules, which I've done up top. I've written my DB name and my collection name and specified the mock data JSON path that I told you about earlier. I'm going to go ahead and clear the collection anyway. I mean, we have a fresh cluster here, so we don't really need to do that. But in the subsequent runs, we may have to. And then finally, I'm going to run an insert of the data set that we have in the JSON file in our collection. And then I'm going to create a couple of indexes. One thing to note here as well, we created trip ID index. This is an additional field that we created. We would normally use the ID field that MongoDB provides. But just to make it simpler in the demo, we just created an additional field. So what you just saw here is me highlighting a block of code and hitting run. So in MongoDB for VS Code extensions playground feature, you can highlight individual blocks and then you can hit run. And this way you can write out multiple queries and you can test them out one at a time in isolation. So here I ran the insert, I ran the create indexes, and now I'm just making sure that my database is populated as well as my indexes are created. And looks like that has happened. So I want to reset back the context, and I want to pull you back to the application that we're building here. More specifically, I want to focus on this part of the application, which lists out all the disputes that are ongoing right now for our support team. And what we're going to do is we're going to use the VS Code playgrounds feature to model the access patterns that we talked about earlier. And more specifically, we're going to model the first two. So here, the query that goes along with access pattern 1 is quite simple. We're going to call the use function to specify the database, and then we're going to so we're going to write a simple query where we're going to do a find on dispute type fair. And this way, our support team will be able to see all the disputes that are of type fair on the UI. The second access pattern relates to fair dispute investigation. So this one's a little bit more complicated, so there's a scenario that I'll walk you through. Let's say our support team receives a fair dispute for a ride starting from right here at Javits Center with those coordinates. The passenger had traveled 16.77 miles, and then the total fare ended up being roughly around $80. And to show you what it looks like on the UI, it looks like this. So here you're just looking at a card, one single dispute. And the highlighted zone shows you the average fare of similar rides in the past. And then on the, I don't know what side you're on, but on the right-hand side, you'll see the actual fare for the disputed ride. So what we want to compute in access pattern 2 is actually create a query for how to display that fare average. So in order to do that, we're going to use MongoDB aggregations. MongoDB aggregations is a framework that you can use to process and analyze data stored in MongoDB with tools such as filtering, grouping, transforming, et cetera. And aggregations are written in stages and executed as a pipeline. So here in the first stage, what we're going to do to create to get our fare average for similar rides is to get all the completed rides originating from roughly 500 meters from the pickup coordinates. So we picked 500 meters as just an arbitrary number that our company policy has. In the next stage, we're going to, based off of those rides, we're going to further filter the rides to have traveled similar distances. So here, if you remember correctly, the ride earlier, the disputed ride that we're investigating traveled roughly 16.77 miles. So here we're going to go plus or minus 2 miles and filter on those rides. The last one is calculating the average fare for all the similar rides that we just filtered down to. And when we run this in VS Code Playgrounds, what we can see is the total average fare ended up being $39.13 for similar rides in the past. However, the disputed fare that we have here costs $80. So this is a clear sign for my support team to say, hey, we should do a secondary dispute investigation here. So just to recap, we covered a lot of things in just a few minutes. So the first one was we looked at our application access patterns before we went into data modeling. And we also talked about some trade-offs of embedding versus referencing. The second one is we used MongoDB for VS Code to connect and populate the database with some synthetic data. And then finally, we used Playgrounds again to prototype queries for our first 2 access patterns. And we tested them and validated them. And we're good to go.
Now that we have our data model pretty much set, thanks to Gaurab, we're going to look at MongoDB Compass, which again is our database GUI, to make sure that we're making the most optimal decisions possible. So first, I'm going to use Compass's schema analyzer. The schema analyzer just gives an overview of the collection that we're on. So we'll give the different fields, the types, distribution, and values. I just click Analyze. It will take a second, and then I can scroll through the results. What I'm really interested in is this light bulb over here. It will tell me if it's flagging an area where I might be able to optimize. In this case, it says that there is a large array detected. I know that you probably couldn't read that. What it said was, as arrays get larger, queries and indexes on that array field become less efficient. You want to ensure that your arrays are bounded to maintain optimal query performance. It's not a huge deal if your arrays are big, but you know what size they're going to be. But when they're unbounded, as in growing without limit, we don't know how it will impact performance. To decide what to do here, we actually need to think about the field that triggered the insight. In this case, it was the checkpoints field. Checkpoints are sets of coordinates that help us understand where a taxi went on a specific route. They're collected throughout the ride, so they can in fact grow without bound, depending on how long the ride is. The way that we'll use this is that in the example Gaurab gave, if, say, you leave the Javits Center and the trip costs $80, but a trip going to a similar destination is only $39, we want to know why. We can compare the number of checkpoints to decide, was the higher cost merited because you were sitting in traffic, or was it unmerited because you took a joyride like my friend's bus? This will look something like this. It won't be displayed on our main page, but if someone is doing a secondary investigation and really needs to look into the checkpoints, they can click on a trip and see a lot of checkpoint-specific data. So the summary for your ride, how it compares to other rides, the average, et cetera. Knowing how we're going to use checkpoints, we can now consider the general advice that we give people who have unbounded arrays in their data set and assess whether or not it's right for us. The advice: extract the array fields into its own collection. This way, instead of the document getting bigger, the collection will just get bigger with different checkpoint documents. Like any data modeling decision, there is a trade-off here. We could stick with the unbounded arrays, which, as Compass told us, will slow down reads and indexes on that specific array field, but it will also impact our other documents because arrays are stored within the document, so as they get bigger, so do the documents. This can slow down queries generally, and as Gaurab mentioned, we do have a limit on document size for this exact reason. The trade-off if we move the checkpoints data into its own collection is that sometimes we'll need to use a dollar lookup. Dollar lookups do have a downside, which is, if you're querying data from multiple collections, you're looking in more places and the queries may be a little slower. We're also breaking that key rule that data that's accessed together is no longer stored together. In this case, we're actually willing to make the trade-off for the number of lookup queries that we would probably need to run. The reason is that if we leave the unbounded array, because the document size will be bigger, we have the potential to impact every query that we run on the collection. The other thing is, we just went through our use case. We're not going to use the checkpoints data that frequently, only for secondary dispute investigations, which are not that common. We're really trying to make sure that the support team has the tools they need to make decisions without doing a secondary investigation. This considered, we can now change the schema using Compass, and this is a 3-step process. So the first thing I'm going to do is use an aggregation to create a new collection for the checkpoints. The next thing I'm going to do is clean up the existing trips collection to remove the checkpoints array. Lastly, I'm going to rewrite my queries to use a checkpoints collection versus an embedded field in my trips collection. To create the new collection, like I said, I'm going to make an aggregation. This has 3 stages. The first is an unwind. This will create a separate document for each checkpoint included. The next thing I'm going to do is only project the fields that I need onto this new data set. In this case, I need the checkpoint coordinates and the trip ID so I can reference it back to any open dispute. Lastly, I'm going to use a $merge, which will write the new collection for me. I will call this checkpoints because this will be the checkpoints data. So doing this in Compass, I'm going to use what we call our aggregation pipeline builder. I've already written the query, but it does break it down into stages for me so that I don't have to write it all at once. We have nice templates which I used, and I can preview the results. If I want to see all of the results, I can use the text view, which gives me only the end of the pipeline. When I run it, it writes the new namespace. I can go to the collection and verify that the data looks how I expected. So this is a new collection that I can access within my database. The next thing that I do is clean up my existing trips database. Like I said, we don't need the checkpoints array field because 1, that was problematic for us, and 2, we've moved this data elsewhere. To make this change, I'll write a bulk update using Compass. To do this, I just have to click the update button. The command is unset, so I'm just going to specify that. I'll list checkpoints as the field that I want to remove. I'll click update. It updates pretty quickly. I just have to refresh. And then I can expand all fields to verify that checkpoints are no longer there. Now that I feel good about that, I can think about my queries. So previously, I had some queries that might involve the checkpoints data, but it assumed that checkpoints were an array field within the trips collection. An example scenario is that I might want to compare the number of checkpoints for 2 trips that have similar start and end destinations to make sure something is standard or identify if the trip was not standard. Luckily, I don't have to do this by myself. Compass has intelligent query generation, which we actually just made generally available today, and I can use that to generate these new queries. So with the caveat that we put some sparkles on the UI that aren't in this for the GA, I will type in my natural language query, which is finding the number of checkpoints for 2 specific trips. I have copy and pasted the trip IDs because they're pretty long. But once I'm ready, I can just click generate. And my query will be generated directly into the aggregation pipeline builder. Again, I can look at the stages to make sure the output is what I expect. If I want to look at the whole aggregation at once, I can once again click on the text view. And these are the results that I was looking for. So more specifically, I can see that one trip had 672 checkpoints, and the other had 548. This probably means that we want to look into the 2 trips a little more, because something may have gone wrong with the top one. Compass was a great tool for helping us verify each step that we took and make sure that we were getting the results that we expected. But we'll really see the impact of these changes as our application scales.
Thank you, Julia, for fixing that for us. So now what we're going to do is we're going to go back to the first access pattern. And to refresh your mind, the first access pattern was about finding all disputes where the dispute reason was fit. So we're going to use this query in order to measure the impact of the changes that Julia made for us. But before that, I want to cover roughly some quick metrics. The first one is the wire tiger cache size. We've intentionally downsized this to 250 megs to show the impact of the changes that we made. But you can imagine as your application scales and grows and gets to millions of users, this is going to be more noticeable. The second one is around document collection size. We've upped the documents in the collection from 1,000 to 20,000. And we've also measured the trips. We've also measured individual documents before checkpoint normalization and after checkpoint normalization. So before, it was roughly around 50 kilobytes. And this time, after checkpoint normalization, it was around 1 kilobyte. So we're going to go ahead and run a simple explain. And this is the result that we found. Before checkpoint normalization, we found that the execution time was around 524 milliseconds. However, after checkpoint normalization, the execution time ended up being roughly around 22 milliseconds. So this was a 23x gain, which is amazing. And of course, this is one way that we fix performance issues that we had today. But there are other ways that you could also address the issue, or you can, deploy these two things at once. But one of them is to pre-compute and store average fare and average checkpoints. And you can even leverage on-demand materialized views with Atlas triggers to accomplish this. So finally, let's talk about some key takeaways. The first one is you can really use Atlas CLI to get started with local development, whether it is deploying local clusters or managing them. Atlas CLI really simplifies that process for you. The second one is considering your access patterns upfront before you dive into data modeling. So as we saw, we were able to think about our access patterns, and we were able to then think about how we want to model that data so that our queries are as optimal as we can get them to be. The third one is using MongoDB for VS Code to really move faster, make your local development environment more efficient. You can use it to seed your database, your local clusters. You can use it to prototype your queries. You can use them to validate all the queries that you're writing before you even write a line of code in your application for database calls. And then finally, you can leverage Compass to detect proactive performance insights. And as Julia mentioned, it is not just about using Compass and leveraging the proactive performance insights when you are at the start of your development journey. You can continue using Compass over time to detect more performance improvements and hints about performance improvements as your application grows and scales. So if you're interested in trying out any three of these tools, you can scan the QR codes here. I'll give it a second. OK, I think I see everyone's phone down. Yeah. And now we can move on to Q&A. Should we go?
Yeah, I guess. Thank you.
OK, questions for Julia and Gaurab?
When you're extracting the checkpoints from the trips collection, would it be a good idea to keep a count in the trips collection so that you don't need to do lookups against the checkpoints collection to get that information? Or is it probably not worth the extra step?
I think it could be worth it. It depends on how else you think you would be using the data. Like counts is just one way. So if that was the only way, it might be worth just collecting the counts. But there may also be, if you don't think you're, let me rephrase that. If you don't think you're going to do it that often, then it might not be worth it.
OK.
Yeah.
And also a comment. The VS Code plugin, it looks a little reminiscent of Jupyter Notebooks. And I'm glad that I will finally have a way to use something like Jupyter Notebooks when using Node. So thank you.
Awesome. Good to hear that.
Anybody else with a question? Going once.
There's someone back there, I think.
Oh, yes.
I have a question about the way we extracted checkpoints. So now potentially we are going to have so many checkpoints, like we had like 500, 600 for one, and now these are going to be documents in a collection per trip, and if you're going to have potentially tens of thousands or millions of, so this is going to quickly grow. Is there any limitation on the collection size that we can have? And the second question is that, second part of it is that would it work if we had followed the same pattern as we had like checkpoints were basically an array, but we would separate them in a document. It would be an array field within a document. The access would be still separated, but it wouldn't be a basically giant collection. Thank you.
Awesome. So for the first one, there is not a limit that I know of off the top of my head. I think it really comes down to how many MongoDB resources you have and whether they can support queries on that much data. For your second question, you certainly can do that. You would then probably get into the business of maintaining different schemas within the same data set, which can sometimes be confusing, which is why we recommend separating it out just for to keep things very clean. Thanks for the question.
Great. I think we have come to the end of the day.
Yeah.
If there are any other questions, round of applause for Julie Gaurab. Thank you so much for your time and your thoughtful presentation.